Today's objective for you guys is that we can find the area and even the perimeter of some irregular shapes, but this time they're going to be sometimes written as expressions, which means that we may have some variables inside. Alright, use your knowledge of area to find the area of the following shapes if possible. Write an expression to show how you arrived at your answer. That sounds great. So let's start with this one. Finding the area of this shape. This is a highly unusual shape that they call a rectangle. And to find its area, what you do is you take the length, which in this case we'll say is 100, and multiply it by its width, which is 60. So the full area of it would be 100 times 60, which is 6,000 and meters squared for the area. Bam! That was awesome. Well, now what they want us to do is take this 60 by 100 meter plot of ground. We're going to say we're going to plant a garden on this. Nice, pretty garden. In the corner of the plot, we want to build a 5 by 8 storage shed. How much area will be left in the garden, and does it matter which way the storage shed is oriented? Let's go ahead and look at that. Let's say that we want the storage shed to be put about right account. And this is 5 by 8. It's not drawn to scale, but that's okay. Well, what is the area of that storage shed? 40 square meters, right? 8 times 5 is 40. Now, what we need to do is that portion, can it be used for garden? No, because it's a shed. So we need to subtract that 40 off of the 6,000 square meters, which leaves us with 5,960 square meters left. Now the next question is interesting. Let's go ahead and take this shed and reorient it right here. Is that going to change the area that's available for gardening? No. All right. What if we took this thing? What if I took it and I placed it over here? Is that going to change the area? No. So orientation and placement are not going to change the area that is available for gardening, which is kind of nice. All right, let's change things up just a tiny bit on this problem. So now we're on 2A. This is pretty much the same rectangle, and if I wanted to find the area, what would I do? I would take the length x and multiply it by the width, 60. Bam. So as an expression, I've got 60x in meters squared for my area. That's this next part. Suppose you have a 60 by 200 meter plot of ground, 2B, on which you are going to plant a garden. You don't want to plant the whole thing, just an area of 8,000 meters squared. Now we know we're going to keep the one side 60 meters, but we got to figure out how long the other one is going to be, which used to be a 200 meter side, right? So, but we want to have an area of 8,000 square meters on these. Then we'll look at the percentage on this, all right? So, the area, let's go and rewrite that. So the area is 60x square meters, but now we're saying that we just want an area of 8,000 square meters. So that means we know the amount of area. We just don't know the length that we want on this thing. So I'm going to replace the area with 8,000 and solve for x, which would be the length on that. So I'm going to divide both sides by 60, and that will be my value of x. So I have 133.3 meters. That would be this length right here, if I wanted the area to have 8,000 square meters. So then it says, what percent of the other side would you be using? Well, the whole length, what it's saying is it used to be 200 meters, but we're only using 133.3 meters of it. So since we're looking for a percent, we can make a percent proportion on these. We don't know the percent, but we know the part of it is 133.3 meters, and the whole length would be 200 meters. So this is the setup, and I got 100 times 133.3 divided by 200 equals x, and the percentage, just by using the fish method on that, 66.7%, which is rounded. So yeah, looking back on that, in the fish method we got 4 values. We're multiplying and then dividing and then equals. So we always start with the x because that's where we're going to end, and we go down to make the tail. So that's 100. Then we went up to 133.3. Then we come down to the 200, and I'm just placing values in this, and that gives us x. Alright, 2C, what percent of your 60 by 200 meter plot of ground will be planted? Alright, so the 60 by 200, that we already know had a total square footage of, well, I guess we'll do 60 times 200. That'd be 12,000 square meters. And we're using, well, I guess that'd be 133.3. So we need to find the area of just the portion that will be planted. And it's a 60 by 133.3 meter lot. So this area of just the planted area, 60 times 133.3. Well, the 3 repeats, so I'm going to make that 8,000. 8,000 square meters. So I'm going to subtract that. Well, no, I'm not going to subtract it. I apologize. If I'm using 8,000 of it, and it was a total of 12,000, then we can set up another percent proportion. X over 100. And this comes out also to be 66.7% of the entire lot. The reason these are the same is because we didn't change the 60 meters. We were only looking, so originally we looked at what percentage of the length is used, which, since it didn't change the width on this, it's going to be the same portion of the garden that's used. Alright, on this next portion, let's find the area of this shape. Now what I'm going to do is I'm going to just make this look like it's a full rectangle. Now if we do, the area of that rectangle is a 60 by 100 meter rectangle. So that would give us, again, 6,000. But this is in meters squared. But this portion right here actually doesn't even exist. So I need to subtract it, whatever the area is. I can see the length is 45 meters, but what is the width on this thing? Well, this length is 12 right here, and this one's 34. The whole thing should be 60 meters, right? So we've got to take the 60 and subtract the 2 that we know, 12 and 34, and that will tell us how long that length is. So 60 minus 12 minus 34, and that is 14 meters. So I've got 45 times 14 for the area of this shape, which I need to subtract off the 6,000. So that would be 630 square meters, which I need to subtract off the 6,000. So my final answer for the area of the actual shape, right here in purple, would be 6,000 minus 630. Very good. 5,300 meter, 5,370 meters squared. Bam. Now let's compare this with 3B. And the nice thing about that is we still know this is 14 meters right here. But if I wanted to find the area of what would be the whole rectangle, like these, what would be the area of that whole rectangle? Well, still a 60 times 100, which is going to give us 6,000. But now I want the area of this red shape again. How do I find that area? Well, length times width. So my length on this one, I don't know what it is. It's an x, and my width is 14. So the area of this is 14x, but I've got to subtract it off the 6,000, right? So the area of the whole shape is really just taking the 6,000, and we're going to subtract 14x off of that. That would also be in meters squared. As it turns out, that is also the answer right there. 6,000 minus 14x square meters. Now you could put that in parentheses if you want. It doesn't really matter to me because we were looking for the expression. Yeah, now they do look the same, right? But we don't know if x, maybe it's like 10 radical. Maybe it's more like, I don't know, 30 right there. Maybe they're even elongating it over here. We just don't know what that length is, some x value. Be careful, we can't take 6,000 and subtract 14x and get 5,986 x's because they are not like terms. We need to be able to remember that, you guys. Suppose you're building a rectangular storage enclosure. The base of the enclosure is to be 60 by 100 meters. You need to construct a ramp into the enclosure as illustrated in 3B. How long would that ramp be if you wanted the remaining area to be 5,250? So we already see the formula for the area. Let's rewrite that like these. But we want the area to have a total of 5,250 square meters. Now, we want to know how long that ramp is. That's what the x is, so we just need to solve this equation for x. Let's go and subtract 6,000 from both sides. So that gives me negative 750 equals negative 14x. And finally, to solve, we'll divide both sides by negative 14, which will tell us the length of that ramp. By the way, the 750 represents the area of the ramp. So by dividing it by negative 14 there, it's going to give us the length. Yeah, 53.57. I'm going to round it to 53.6. And that's in meters. So that would be the length of the ramp, given that area right there. All right, 4A. Once again, I'm going to treat this like it were a full rectangle right here. Okay. So the full rectangle, its area, we're going to keep these as fractions, by the way. So I have a length, 9/7 times the width, 7/8, which we can cross-simplify the sevens. And we have 9/8 square yards. But we have this portion, this rectangle radical, that we need to subtract off of it. So that area would be 3/5 length times width, 1/3. And the 3's cancel out on that. And we end up with 1/5 square yards. So in the end, we end up with 9/8 minus the 1/5. What do we need before we subtract fractions? Common denominators. What denominator should we use? I'm going to use 40. So I'm going to multiply the 8 by 5 and 9 by 5. That's 45/40ths. I'm going to multiply the 5 and the 1 by 8, which gives me 8/40ths. And I am subtracting these. So 45 minus 8 would be 37. And this is in 40ths yards squared. Bam. That would be the area of this rectangle stuff. This irregular shape. Alright, so this one is similar, but also there's one huge difference on it, these. So I'm going to find the area of this full rectangle, which would be, I've got 7/8 times x now, and that's in yards squared. But once again, I need the area of this rectangle as well to subtract from it. So that area has not changed. 1/3 times 3/5 is still 1/5 square yards. So I'm going to take my 7/8 x yards and subtract this 1/5. That would give me the area in square yards. Can I combine these two though? Nope. So it is done. We want to find the area and perimeter for this figure, but before we find the perimeter, let's just start with the area, alright? So we could split this up, radical, and say we've got two rectangles. I'm not going to do it that way. I'm going to change it into one big rectangle and then subtract the missing area. So I've got this one, this big rectangle, and I'm going to subtract off this one. So let's find the area of the big one first. So we can see the length, I'll say, is 14, and then the width is 7, so I got 14 times 7x. So I've got 14 groups of 7x's. I've got 98 x's. Yeah, we can multiply these because I've got 14 groups of 7x's, which gives me 98 x's. Before we could not combine them because I can't take x's and combine them with just ones. It would be like saying the same thing as I'm going to combine oranges with toads. Toads? Right? Toads.
Oh, I see that.
Toads and oranges are both things you could eat, but they're very different, so we cannot combine them. If I had one toad and one orange, it doesn't give me two oranges, and it doesn't give me two toads. It gives me an orange and a toad. Done. Now I need to find the area of the red rectangle. But I have this width right here is 3x, but I don't have this length right here. But we can figure it out, right? What do you got? Very good. So let's show that it's 14, which is this full length, but 5 of them are used radical. So I got 9 on that. So the area of this would be 9 times the 3x, which gives me 27 x's. And I'm going to subtract those off of the 98 x's, which gives me 71 x's in units squared. But that is not all. We also need to find the perimeter. So we already found the length, radical. That's 9. But there's also this missing length, radical. Well, if this full length is 7x and this length is 3x, then how many x's is this length? It's got to be 4 x's. Okay, so to find the perimeter of this shape, I've got to take my 7 x's and add it to the 5. I'm just going to go clockwise. Then I've got to add that to these 3 x's. Alright, now let's go ahead and add the 9er. And then I need to add this 4x. And then I'm on the bottom portion. So we're going to add 14. Now, this is a big expression. We can't combine x's and numbers. We can just combine x's with themselves. So let's go ahead and look at that. I've got 7 x's, 3 x's, and 4 x's, which totals 14 x's. Then I've got this 5, 9, and 14, which is a positive 28. That is my perimeter. And we don't know the units, so we'll just put units on that. The perimeter is 14x plus 28 units. Alright, 6 has a couple ways, but the most common way to solve 6, because we're just looking for area on this one, is most people I see cut it up like these. So I've got the area of this rectangle, which is d times 12. I'm just going to say it's 12d. But then this triangle down here, the base is still 12 right here, But what is this length here on the side, the height of that triangle? So this length is d radicale. And if the full length is d plus 6, then what's the length of just the purple portion? 6. Yep. So if I wanted to find the area of this, it's a triangle, so I've got 6 times 12 divided by 2, which looks like it's 36. So the area of the rectangle is 12D, and the area of the triangle is 36. So that would be the full area in units of this shape. Sorry, thank you. Units squared, that's better. Find the area and perimeter of this figure as well. So once again, I'm going to treat this as a full rectangle. So I've got this full rectangle radicale, and its area is 15x times 7 is what it looks like. So that appears to be 85 x's. But we have this rectangle here that we need to subtract off. Its area is 5 times, what's this length radicale? Well, again, if this whole thing is 15 x's, we got 5 x's radicale and 3 x's right there. So that would be, yeah, 7 x's right there. So if I totaled all three of these up, it would give me 15 x's, right? So that's what we wanted. So I've got 5 times 7 x's, which is 35 x's. So I need to subtract that off of the 35 x's, which would be 50x. Let me go back. The 80. Yeah, that'll change some stuff. That's not 105 x's. I'm sorry, 85 x's. That's 105 x's. 15 x's times 7. So 105 minus 35, bam, 70 x's in units squared. So that's the area of the whole shape. But it also wants perimeter. So with this, I'm going to go back and label this one as 7x. And then we know this one also is 5 radicale. So then I can get rid of this stuff. Now, if I look at the perimeter, I'm just going to add all these up. I'll start with the left side, which again we could label that as 7. And then I will go clockwise. So I've got 7, 15x, 7, 3x. Not going to have enough space. Then we've got 5, 7x, a 5, and a 5x. We're just going to add all these together. So starting with the 7s, or the numbers, 7, 7, 5, and 5. That gives me 24. And then I've got my x's, 15x, 3x, 7x, and 5x, which appears to be 30 x's. That would be my perimeter on this one in units. Bam, we did it. Find the area of this figure. So on this one, we are going to split this one up again into a triangle and also a rectangle. So if I look at the rectangle, the area of this one, I've got a 4 by 9m. I guess that's probably not meters right there, you guys. That appears to be a unknown. So that would give us 36 m's. And now we want to find the area of the triangle. So if this is 5 m's, then this one has to be 4 m's to make up all 9 m's. And this length radicale, 4 of them are used up of the 10, so this has to be 6. So I've got 6 times 4m, but we're going to divide that by 2, which gives me 12 m's. So the area of both, I've got 12 m's and 36 m's, which when I add, I get 48 m's. in units squared. That would be my area.
It looks like 48 meters. Oh, okay.
Yeah, the M thing is kind of tricky. We'll try not to use variables that can also be replaced with some type of units on that in the future. A bullseye is made of two concentric circles as shown below. That just means that there's a circle in the circle. The radius of the smaller circle is 4.5 inch. So we can label those inches radical. And then we got another inches. The larger circle has a radius of 9 inches. So if I wanted to find the area of just the smaller circle, radical, then I've got the area of that circle is the radius, 4.5, times the same radius, 4.5, times pi. Now, we're not going to use 3.14 as pi. I am going to use pi as pi. So, in my calculator, when I multiply this, the area of the smaller circle is, rounding to the tenths, 63.6 inches squared. So that is the answer for A. Alright, now it wants us to find the area of the big circle, radical. So the area of the big one, it already told us to add a radius of 9, so I'm going to do 9 times pi. And that would give me rounding to the tenths. So that's what I get for my large circle, which I'm going to put in up a count, 254.5 inches squared. Now see, we want the space between the smaller circle and the large circle. That's the gray area. So we're going to take the large circle, 254.5, and we're going to subtract the small circle, because it's empty, 63.6. And out of that, we get the area of just the gray area. 190.9 inches squared is the area of just the shaded gray area. The next part is, assuming the dart hits the target somewhere, what is the probability of hitting the smaller circle's area? So this is just a percentage on these. So the percentage of hitting that is, well, the area of that was 63.6. We're going to divide it by the area of the whole thing, which is 254.5. Now as a decimal, and you could set up a percent proportion on this, by the way. So I've rounded that, which if we change into a percent or round it, I'm just going to make it 25%. You can make it 24.99 if you want, but 25%. What's the probability of hitting the outer ring? Well, the outer ring had an area of 190.9, and we'll divide it by the full area, 254.5 again. And that will give us the probability, as a decimal, of hitting just the gray area. And I got 0.75 and some zeros, so we'll just make that 75%. And that makes sense, right? Because if you hit the target, you either have to hit the gray area or the white area. If the white area takes 25%, then you have to have a 75% to hit the other portion to make it 100%. We'll get more into that in a different unit. So number 10, we're going to find the area of just the gray area again. So let's look at the circle in black right there. That has an area of, the radius is just h, which is shown radical. So I've got h times pi. And the whole thing has a radius radical of j. So the full circle has an area of j times a pi. So if I wanted just the gray area, I'm going to make that j squared times pi, and I would subtract the h squared times pi. That would be the area of just the gray portion. The figure below shows a circle and a rectangle. The circle's diameter is equal to the rectangle's base. Find the area of shaded region and its perimeter. Okay. Well, what we could do is just cut this in half right account. Alright, so the area of these, of the whole thing, would be 3x times 2x's. So that's going to end up being 6x squared. But, and if we look at this, the radius of this circle is just 1x because the whole diameter is 2x's. So the area of just the circle is going to be radius, which is x, times the radius times a pi. That would be an x squared pi. But we only got half of that circle right there. Okay, so I'm going to cut that in half. So if I took my full area of this purple rectangle, I've got 6x squared. And what I need to do is subtract, let's say pi over 2 x squared. I've just rearranged that. I'm okay with this being simplified for now. We don't need to worry about subtracting pi from 6 or pi halves. So that would be the area of the gray section. Bam. I may have spelled gray wrong again. Whatever.